But
Flat curious, globe skeptic, it's all the same thing. They're all flat earthers that just haven't admitted it yet. Right?
Yeah.
It's the people, the only people that believe in the globe are the people that don't know what their model is and don't know what our model is and have a wrong impression of our model. People that defend the globe know less about their globe and more about what ours is not. The straw man, Earth is rising. It's a disk in space. All of that stuff. They have, we're gonna
the
do
disk
it.
in space. Yeah, that's the main. Yeah,
it's so
main
stupid.
Misconception.
It's so stupid.
Welcome everyone to watch the AnCast Estonia podcast. This time we have 4 people here. We're doing a Zoom call. And we're talking about flat Earth versus round Earth and misconceptions and understandings. So I guess it will be an interesting time, so get ready. And we have today with us David Weiss, also known as Flat Earth Dave, from America, I guess, from somewhere.
East Coast, near New York City.
Ah, nice. Okay. And Reimo, of course, my partner in this show. And Erik, my good friend and colleague from my workplace. So, so let's start. So, flat Earth and round Earth. So, Erik is the person who believes 100% that Earth is round, as I used to believe back in the years. So, and there were many things that changed my mind because I saw that there was more evidence towards flat Earth than the round Earth. So, let's start. Is there a first question? Reimo, did you have some kind of first question? Or Dave, did you have some kind of thing you wanted to say for introduction?
There's... go ahead, Erik.
I just wanted to add that this is not intended to be a debate. But
no, it's a discussion. That's all.
Discussion. So we want to actually hear what you have to say.
Are you guys not seeing him talking? I'm like he's talking, but his mouth isn't moving.
Who?
Erik.
Oh, it's I am talking Reimo.
Oh, okay. There you are. I'm looking at Erik. I'm like, why isn't his mouth moving? All right. Sorry. That was
Everything
funny.
is fine.
All right.
But I think
Dave, you can begin, and
I'll give it to I, like everyone else, thought flat Earth was the dumbest thing ever. I banned people from our social media, from our podcast, for even suggesting that I look into flat Earth because it's so dumb. There's so many proofs. We live on a ball, boats over the horizon, Sticks and Shadows by Aristophanes, seasons, day and night, sunsets, all of the stuff. And then I was forced into looking, and I went in with a closed attitude. I'm like, there's no way this is real. I'm just going to prove the globe and disprove flat Earth. And it took about 2 weeks before I came out the other end going, oh, my God, the Earth isn't a globe. I don't know what it is, okay? But it's when people say there's no proof of the flat Earth, it's because they don't know. They actually don't know what they're saying. There's tons of proof of flat Earth. There's no proof of the globe Earth. Things will fall in this discussion into 3 baskets. Works only on a flat Earth, works on a flat Earth and a globe Earth, or works only on a globe Earth. But you'll find out that last basket is completely empty. Nothing ever goes into it. It makes you make things that make you go, So the one thing I find out about globe believers is they don't know about their globe. And Erik, I'm going to ask you a couple questions. When I was asked these questions, I got them all wrong when I was you. So if you get them all wrong, you're as smart or as dumb as I am. Okay? How fast is the Earth spinning at the equator?
24 hours, one round.
So how many miles per hour is it spinning at the equator?
Have to don't remember.
All right, so that's fine. How fast is the Earth orbiting the sun in the heliocentric model?
You mean
how many miles per hour the Earth is going? Hold on. The Earth is going around the sun like this, right? So how fast is the Earth spinning at the equator?
No.
I mean, no. I mean orbiting. Okay. And how far is the sun? How big is the sun? Do you know these numbers? These are things that people don't know, but they defend the globe. How did we figure out how far the sun was? Okay, and that when you understand what they did, how they did that, you realize it's complete and total nonsense. How did they figure out the radius of the Earth? Because everything in our solar system and the galaxy is based off the radius of Earth, and the way they got that number is it's a made up number, it's assumed number. So you start with an assumption, you end up with garbage. So this is what we're supposedly doing. The sun is traveling at 500,000 miles per hour. We're orbiting at 66,000 miles an hour. Okay, and we're chasing the sun at we're spinning at 1,000 miles an hour. We're orbiting at 66,600 miles an hour, and we're chasing the sun. All of these are curved trajectories. The spin, that's a curve. So you're not going in a straight line like an airplane where you can drink a glass of water and walk to the bathroom. You're spinning. You're dropping down at a mile every 2 minutes or something like that, or even more, even faster than on the spin of the Earth.
I believe the backstage theory. That's the correct theory. But is your background image or this movie is this
is what they're telling us.
That is correct.
Yeah,
I believe this.
You believe this is correct. So yes. You believe that we're chasing all of the planets are staying on the same plane and they're chasing the sun. Here's the sun, and all the planets are staying on the same plane.
Yeah, because of the gravity, sun gravity is so big.
Which gravity? So which gravity? Einsteinian or Newtonian?
Sun's gravity.
All right, so we'll get it. Hold on. Let me finish what I was saying, Eric. Eric, you're just throwing words out there. You don't know what they mean. Gravity, when you say gravity, is it Einsteinian gravity or Newtonian gravity? Is it based on mass or is it based on the bending of space-time? Okay, they keep changing what it is, and gravity is just a theory. So you're basing your belief on a theory that scientists don't know how it works. And there's major problems with it. But let me finish where I'm going here. I'm going to try something, and hopefully it'll play. It'll play. So this is let's see if this works. Of course, it's probably not going to work. Hold on. Why isn't that going? Of course, it's not going to go. I go like this. And why isn't it going? Here we go. Interact. All right. So this is the hypersonic sled track. Can you hear this? Did you hear that? Actually, it's coming through my speakers, but I'll let you listen this way. So this is going by at Mach 8.6. This is half speed. Let me just back it up one more time. Okay, just remember the speed.
Right.
You can't even see that, okay? You can't even see it. That's Mach 8.6. My microphone is falling over here. Sorry about that, guys.
8.6.
So Mach 8.6. So you have to believe. Sorry, guys. My equipment just got hung up. All right. So you have to believe that we are traveling 10 times faster than that around the sun and 100 times faster than that around the chasing the sun. Okay? But meanwhile, we have, when you go out into nature, we have lakes that look like this. This is perfectly calm. Now, on the spinning globe, the big cosmologists out there, they tell us that the water bulges at the equator due to centrifugal force. How come the water's not bulging here? How come lakes show that we are completely stationary? We're not moving. And just remember, acceleration is when you change vectors. If you're driving in a car at 1,000 miles an hour or 100 miles an hour or even 50 miles an hour and you had a dinner plate filled with water, as soon as that car turns the slightest bit, like the spin of the Earth or the orbit of the sun or the speeding up and slowing down, that water is going to slosh all over the place. But we have lakes that just look like this.
Yeah, water must be flying around.
Well, they're telling us it bulges.
If you spin this taldrik, I don't know what this
plate.
plate, then the water spins out of it.
Right. Okay. So we're
impossible.
Well, that's very good that you said that. So think about this, right? The heliocentric model, nothing exploded, created everything. Then all of the rocks and matter just turned into planets, and all of the gases turned into other gassy burning balls that are even bigger, and they left a vacuum in between. So now we have burning balls of gas in a vacuum. That's impossible. Then we have rocks with water and air on the outside adjacent to a vacuum with nothing holding it in. Breaks the second law of thermodynamics. You can't have high pressure next to low pressure without a physical barrier. And then the Earth is spinning, corkscrewing, flying through space, and all of the water stays perfectly flat. When science tells us that it actually bulges 14 miles high at the equator, which means if you're flying from the northern hemisphere upside down to the southern hemisphere, you'd have to triple your altitude, your cruising altitude of about 5 miles to 14 miles just to skim over that hump of water. And we know that never happens. There is no hump of water. Yeah. Okay? So
what do you mean?
But
the moon is rising the water in the equator because the moon has the gravity to rise it on the equator.
So we want to talk about that. We'll talk about tides. I was going to go. Yeah. So tides make absolutely no sense. So this is the official story. Hold on. You got the Earth, the sun, and the moon. Okay. Yeah. When the moon's over here, we have a full moon, right? Because the sun is lighting up the moon. You with me?
Yeah.
Right. When the moon is over here, we have a new moon because the sun's lighting up the backside of the moon, so we don't see the moon. Which there's major problems with that. But when we have a full moon, there is a correlation to when there is a high tide. It's a higher high tide. Okay, because the gravity. This is what they tell us. Now follow me here. If my head was the moon, here's the Earth, and this outer blue is a high tide. And they're saying that my moon head is gravitationally pulling the water away from the Earth, creating a bulge. You know what else they say? Well, how do you explain that there's another high tide on the other side of the Earth at the same time? Because the tides are up 6 hours, down 6 hours, up 6 hours, down 6 hours. So on the other side of the Earth, there's a high tide. And this is the official explanation in my former globe belief system, is that my moon head is pulling the water away from the Earth here, creating a high tide, and it's pulling the Earth away from the water on the other side, creating another high tide, and the Earth is rotating. It's dumbest crap ever. But this is what science tells us. This is what science, when I say science, it's not real science. It's called scientism, right? Because they just make crap up. I'm telling you the official scientism explanation, and you're going, no, that's too dumb. That's what you believe if you believe in the globe. Dumbest crap ever. And then when you actually look at tides across the Earth, there's major problems. There's high tides, low tides in different areas. There's areas of the Earth that never have a tide in the salt water. In the middle of the ocean, there's no tide in this certain spot. That makes absolutely no sense. Absolutely no sense.
Current systems also, and that is related to those current systems, and it's complicated. It's not so.
Well, it's not that. Well, so here's another thing, right? The sun has gravity. So when we have a full moon, we have a bigger tide. Well, what about when the moon's over here? There's a new moon. We just can't see it. It's just not lit up by the sun because it's the dark side. There should be the moon's gravity and the sun's gravity, making even a bigger high tide, but that's not what happens. So the gravitational idea of tides is absolute nonsense. If you ask me, I think that the moon and the sun are electric and magnetic in nature, which has to do with gravity, and that electric force is what makes the world work. right? The world is a giant battery. There's free energy. The sun and the moon are the anode and the cathode of the battery system. The salt water carries the current. As we know, salt water does carry current versus fresh water. And the land is the salt bridge of the battery. Okay? And as the sun and the moon travel around in between the tropics, they're pushing a wake, a magnetic wake, electromagnetic wake. And that has something to do with the tides. There's also some really weird stuff going on in the north. Haven't been there, so I can't tell you. But what I can tell you, what I can show you, which I've already shown you, is the official explanation is complete and total garbage, and it's not correlated to the moon, because a new moon right next and lined up with the sun should create a higher tide, and it doesn't.
Mm-hmm. Okay,
right.
How can you explain this? That the sun won't why the sun won't rise at the same time in flat the Earth theory? It should rise at the same time in New York and here.
No,
because if you
have a misunderstanding.
If you do that, it will go black and night and day in the same time.
Yeah, so
flat, or this way.
So it's Eric,
impossible.
Eric, I want you to wipe that idea out of your head. You've been Hold on. I'm going to explain that your idea is completely nonsensical because you've been programmed, because you Googled flat Earth and the propaganda got to you. They fed you these straw man arguments, these gaslighting arguments that no flat earther believes. We don't believe that the sun goes up and below Earth. Earth is not a disk floating in space. It doesn't work that way. So let me show you how a sunset works on Earth, and then we'll get into I'll show you how that works. So this is my kitchen right here, and I strung a line. Hold on. This is called, take about a minute, right? This line is level, and we're viewing it from what I call a celestial point of view, from an elevated point of view. And I got a little flashlight here. That's my sun, and I'm going to move the sun along this line, and the counter is down here. Excuse me. Down here. And this here could be a city skyline, mountain range, or it could just be the cloud deck where you can't see through it anymore. But the sun never goes below it. Now, at the same time, I have a camera on the other end of the far end of the counter, on the counter, okay? And I'm looking up, and look at this line. It looks like it's going down. If I showed you that line first, you would say, that's not level. And I'd say, is the sun going below this opaque barrier? Right? And you'd be like, well, yes, it is. And because it's in the distance, it looks like it's at my eye level. Like if you were sitting at the bottom of Mount Everest, the top is way up there. But if you were 30, 50, 100 miles away and you could still see it, the top would be at your eye level. So as we go, look at the sun. This is me just moving it away. This is at eye level. This is a real sunset. The sun is going behind the atmospheric deck of opacity. Okay? That's all it is. It's perspective, and when the sun goes away, it takes its light with it. With it. So here is I'm going to show you a couple quick sunsets, and then I'll show you how it works. And you'll see this is just going back and forth. The sun comes, and I think it's this one reversed. So here it just comes. It brings its light with it. So hold on, let me find a better one. All right, here's one in Bulgaria. Super clear day, elevated position where nothing in the distance is above their eye level, because if there was a row of trees, a city skyline, or even a cloud deck that's above your eye line, the sun would go behind it. But it doesn't. The sun just goes away. You'd have to believe that you're falling over backwards faster than the speed of sound. Okay? But the truth is, the sun is just circling around. It looks like it's going lower, but it's just going away, and it takes its light with it. One more, and then just to really knock it home here. So, where is it?
Your drone footage.
Yeah. That's what I'm going for. You know my show. So here we go. This is on a super clear day, not looking over water. It's below freezing, so there's no humidity in the air, super clear. And the sun in 5 minutes was way up here and it went down, 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 down. Now, if we were spinning, it would just keep on going, but it didn't. It went down, 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 and then it just sat here. It sat here. This is super sped up. It sat here for 10 minutes. And instead of dropping down because we're falling over backwards faster than the speed of sound, it just couldn't push through the atmosphere anymore, and it went away, showing it again here back and forth, right? So it shows that we're not spinning, okay? We're not spinning, and the sun just goes away. Same thing, Afghanistan, super clear, super dry. The sun is just going away. Now, this hill here is above the eye level of the viewer. So as the sun appears to get lower and lower due to perspective, it just kind of gets, actually, that's not above the eye level. But it basically back here, it just goes and it takes its light away. It takes its light with it away. And this is streetlights. These are all level. Mm-hmm. Eric, you have to look. These are level, and here's the sun going away. Then the atmosphere becomes opaque. You think it's going behind a horizon. It's not. So let me show you how. So basically what we're showing you is as the sun moves farther away, it... Uh-oh. Hold on.
Listen, Dave, I think Eric might be still missing what's a flat Earth is. Can you show some graphics?
I
flat Earth is?
I saw everything because it's
the disk in space. Yeah,
equator sun is dropping down fastly, and in here Estonia and Finland, we have days when the sun doesn't went down at all.
It doesn't go down at all. So I'm going to show you exactly how that works right now. Right here. So this is so pay attention here. So right here, this inner yellow line is the Tropic of Cancer. You've heard of that. And out here, the outer yellow line is the Tropic of Capricorn. And the red line in the middle, with the sun is almost directly over right now, is the equator. Okay? And so just remember, when the sun's close to you, as it gets closer, it rises. As it gets farther away, it drops down. It can only go so far away before it disappears. Its light doesn't go forever. Light years, light traveling for billions of years, that's all nonsense. Light is just like a sound wave. It only goes so far and then it fades out. So during the year, the sun migrates in between the Tropic of Capricorn into the Tropic of Cancer. Right now, it's almost halfway in, and in a couple of months, I'll jump forward to June. In June, it's over the Tropic of Cancer. Now, look where Estonia is. I think you guys are over here somewhere. The sun never really gets that far away from you in its circle. So the sun never sets, right? The sun never sets. Meanwhile, in Antarctica, it's dark. It's dark in Antarctica and the sun never rises because it never gets close enough. 6 months later, and so we're having our summer, right? The southern part of the United States, super hot. Estonia, you guys are having your summer. Australia is having their winter. 6 months later, the sun moves out to the Tropic of Capricorn. They have their summer. The sun is higher in the sky, just like those streetlights. If you're standing under a streetlight, that's your summer sun. The streetlight down the road, that's your winter sun. It's farther away. It's lower in the sky. Even though it's the same height, it's farther away. It's lower. Therefore, you have your winter. This is Estonia's winter, and this is Estonia's summer, when the sun goes in and out. Okay? 6 months out, 6 months in. The moon does the same thing, but every 28 days.
So basically, the sun is... Eric, basically the North Pole is in the middle and the South is around. So the sun is revolving or circling around the North Pole, sometimes like a smaller circle, sometimes wider circle, and that creates the seasons.
The important thing is that we are not a disk in space.
Yeah, it's not this. Do you have, Dave, this picture where there are planets and there's one Earth is disk? So it's like so. I believe Erik thinks that there is a floating disk in space.
I mean, this eclipses, how is this possible with flat Earth?
Right. So,
Sun eclipse.
So this is what globers think flat Earth is. They think that, we're a disk and all the other planets are round. None of that is true. As far as eclipses, so we're jumping all over the place. This is what flat Earth is right here, okay? Flat Earth is, Antarctica is not a continent. Hold on, let me pull that up. This is what they tell us. Antarctica is the highest land on Earth, and it's at the bottom of the Earth. I always found that very weird, okay? And if you look, pictures of Antarctica from space, there are none, okay? Let me show you that, too. It's one of the only places on Earth where you just get cartoons. These are admittedly cartoons, all right? So why aren't they showing us Antarctica? The reason is because Antarctica is not a continent at the bottom of the Earth. Antarctica is the container of our world pond. If you had a bathtub of water, large bodies of water at rest lay flat. That's it. If you got rid of the tub, the water's gone. If you have a puddle or a lake or a pond, the container is the shoreline that surrounds it. And the shoreline is where it's higher than the water consistently. Lower that shoreline, the water is going to flow out. Okay? The container for our world pond is Antarctica. Antarctica is the highest land on Earth. It is the container of our pond. We live in the Antarctic basin. That's it, right? And this is how it works. Just and the one question you're going to come up with: what about circumnavigation? Okay, how do people circumnavigate? And this is how it happens. At the center is our magnetic north. I got a magnet here. I got a compass here, and the compass needle is pointing towards the north. Well, I'm trying to push this compass west. I have to turn to the right to maintain a westerly heading. If I go straight, I'm no longer going west, okay? And if I want to go east, same thing. That needle has to constantly point to the center. So east is a circle. This does not prove the Earth is flat because it's the same thing on a globe. Okay, there are some issues on the globe, though. Like at the equator, you don't have to turn, and in the south, you'd have to turn to the south, and that's not the experience that ship's captains have. They always say they always have to correct to the north. If I try to go straight, dead reckon west, and I don't turn, I'm heading south. South is every direction away from the center. South is every direction you can possibly point. That's south, that's south, that's south, that's south. South is away from the center. So here, billions of people have circumnavigated east and west. Billions, right? It happens every day. People are doing it. Nobody has gone south and magically popped up on the other side of the earth. No one has gone from Santiago and shown in Australia. Here, I'm going north, north, north. As soon as I pass the North Pole, I'm heading south. Still going in a straight line, I'm going south. So that's how circumnavigation works. Isn't it weird that no one has circumnavigated south? Nobody has ever circumnavigated south. Now, if you Google that, you're going to see that there's a world record for a guy called Spider Tracks, and he did a trip where he went, from Alaska down to California. He went to Santiago, then he went to the South Pole, and then he said, oh, the weather was too bad, so he turned around, went up through Brazil and back around, and we're like, all right, he didn't do it. And Guinness Book gave him the world record for southern circumnavigation. This is all he did. He went up here, he went down here, he then went over here. He just did a little circle in our flat earth pond. That's it. No one has circumnavigated south. That's a problem.
Okay, please explain me how is this possible that we have the sun down and you in America, what time is it there?
So I explained it already, but
you mean we have night and there America is light time, flat earth, it should be the same time.
No,
rising sun.
Absolutely not. So
it's possible.
So here right now, it's almost noon where I am. So I am right here. Right here. Okay? And so it's almost noon. We're almost near the equinox. So we have equal day and equal night. And you're over where? What time is it where you guys are?
It's 18:30.
18. So that's 6:30. So you guys are right over here about this on this line right here, right?
Yeah.
So the sun is setting right now because the sun is going away from you. Okay, it's like if you and I were in a room together and there's lights in the ceiling, right? And I expanded that room to 10 miles. This is a smaller version of the flat Earth, and you went 5 or 8 miles away from me or whatever. You would no longer see the light above my head, and its light would not be able to make it to you. You'd be in the dark if there was no lights over there. Okay? Perspective. And then that's just in a room that doesn't even have atmosphere. And you have this atmospheric cloud deck in between us. Everything just gets merged together. Anything above it goes behind it. Anything on the Earth's surface just gets squished. And when you zoom in, you could open it up again. Let me show you that. So when we look into the distance, people say, well, "What about boats over the horizon?" And I've seen boats disappear from the bottom up. You think you did? They actually did disappear from the bottom up, but it's not what you think. So out here, there's no boat. Okay, but what I'm doing is I'm zooming in. So the horizon's where the sky meets the ground, but I'm zooming in and I'm increasing that space in between my hands, and all of a sudden there's a boat there. Okay?
Erik, näed?
Yeah, and so when I zoom out, now watch this boat, it's going to disappear from the bottom up. Now this is the same as if the boat was sailing away from me. The hull's gone, the windows are gone, and the whole boat's gone. Now a glober would say it went over the curve. No, it didn't. It just got out of your angular visibility to see. So here's a question. Can my finger cover half of my face, like up to my nose? No, it can't. But if my finger was one of these little waves here, and you're looking at a wave that's closer to you,
yeah,
it's all perspective. It's all how the angular resolution limits of our eyes are. And there's millions of examples of this, right?
So
here,
basically,
wait. Last thing, when you look out from this beach here, you can't see this building. It's like that boat. It's gone. Its angular size is too small. But we zoom in with our super zoom camera lenses now. There's the building, and the bottom floors are missing. But here. There's an optical thing going on here. These balconies are all the same height, 10-foot high ceilings. Well, look, they're getting crushed here. They're getting compressed. It's an atmospheric density issue. And then these little waves here in the foreground that are miles and miles and miles in front of that building are like my finger, like that, right? Even though, it's just a little bit above your eye line, everything is getting smaller and smaller. Like here. Can this ball hide behind my finger? No, it can't. But if this is in the distance and the ball is getting smaller, okay? It's getting smaller. It's hiding behind my finger. Okay? The whole thing is hiding behind my finger. How's that possible? Right? It's perspective. They don't teach you perspective in school. They don't teach you about the angular resolution limits of your eyes. They don't teach you about the inverse square law of light, because you might discover where you live and then you might unplug yourself from. I have a new word for the heliocentric universe. It's called the matrix. They don't want you unplugging from the matrix.
Yeah, I wanted to add one thing. Basically, if we look from a 3D, let's say this is Earth, and it's basically like a plane, and the sun is just going like it's pretty much up here and just circling around on this plane like this, and it never goes higher, never goes lower. Earth never goes higher, never goes lower. Earth stays in the same place. Just the sun is making these circles just around.
But you can directly make the same tests with sphere. You can take light and you can take a sphere and look, and because if it's Estonian sphere, you're just taking around. In the summer, Estonia is showing because the sun is like, it's the same.
Basically. Okay, all right. So this is what you're saying.
We can also imagine that, or this is also true.
So you're just saying things that you've been programmed to say, and you're not really thinking about them. So let's think about them. So they tell us, and I'm going to use Jupiter because it's just easier to see. So I got the sun. The Earth is tilted. So here's the northern hemisphere on the top, southern on the bottom. You believe that we have seasons because when we're tilted towards the sun, we're getting more direct sun rays. And when we're tilted away from the sun, those sun rays have to spread over a wider area. Okay? Is in the helio-nonsensical matrix model, is the Earth closer to the sun or farther than the sun during Estonia's winter?
The orbit is also elliptic.
I know, elliptical. So there's a certain time of the year the sun is 3.5 million miles farther from the Earth. During Estonia's winter, you guys get freezing winters there, right? Things freeze, the lakes freeze in Estonia?
Yeah.
Okay, so during your winter, is the sun closer to the Earth, 3.5 million miles, or 3.5 million miles farther from the Earth?
Have to check it out.
Okay, well, the good answer, because you don't know, the answer that they tell us is that we are closer to the sun. So, if we're closer to the sun, and at solar noon during the day and December, when it's December 21st, when we're at the farthest, that at solar noon, the sun is pretty high in the sky, not as high as in the summer, and you can look at it, you could barely feel the heat on your face, right? It's got a pretty direct angle. It's 3.5 million miles closer than it is during your summer. And you can look at the sun, you're not going to get tan, you're not going to feel much heat, and you're going to go inside and sit by the fire, okay? But during the winter, now during the summer, right? That example I just gave you was the winter. During the summer, you can go down to the ocean or wherever you can see the sunrise, and as soon as the sun appears into the optical horizon, you can feel the heat on your face. You can get a tan. You get warm. Well, that's the most severe tilt the Earth can be. That's an 89-degree tilt. 1 degree off the horizon, you can feel the heat. You're farther from the sun. Okay? Okay? None of that.
The other side of the sun.
Yeah. What do you mean the other side of the sun? It doesn't matter what side. What, one side hotter than the other side? Is that what you're saying?
The elliptic is the other side.
So we go.
The same. The same way.
So here I'm tilted away from the sun, and I'm closer, and then it goes over here. I'm tilted towards the sun. But listen, you're not thinking, because tilt it this way or spin it, it's still the same tilt. If I'm standing right here, the sun is directly over me. As I spin away, the sun is dropping. It's at a much more angle, right? The angle is much worse. If the tilted model was real, it would be freezing arctically cold every day at sunrise, especially during the summer when the sun is.
No. It's sun is here and it's going around. It's tilted now towards, and it's summer. It's going the other. It's orbiting. The Earth is orbiting. The sun is the center, and it's turning like you showed before. This image background.
I think we're going to have to pass on this one. I don't think that you're able to conceive of what I'm saying, and maybe it's something you can get a couple models and get a globe and get a heat lamp and try to figure it out. But there's the tilted model, the globe, the anti-flat earther globe opponents out there. They won't even bring up seasons because seasons destroys the globe. You're just not understanding. Let's move on.
I have one more thing to add here. Actually, when, let's say, there's winter time here in Estonia, and let's say we are farther from the sun, so to speak, then even if the Earth turns, then there should also be cold in Australia, but they have summertime, don't they? So they should also have cold time, because we're farther from the sun and we've got closer. Then we should have summer in Estonia and in Australia.
Yeah. So the answer to that is, they say it doesn't matter the 3.5 million miles compared to the 93 million miles. It's only a few percent, and that's not what it does. What it is, it's the sun rays coming in. When you're tilted towards the sun, you get direct sun rays, and when you're tilted away, you don't get as much. That's what they tell you. But the spinning of the Earth, totally 100% disproves that. Okay. So, here is a model of the Earth. Let me just pull this over a little bit. Okay. Here's a question for you. So, if you were here, pay attention. If you were here and you're on the far side here, you're on the equator, let's say, and it's midnight, you're on the side where I'm pointing. You're literally, if the sun is right there, right? You're standing, well, I got it the wrong way. You're standing here on the side, right? You're standing right there. So it's midnight, and you look up at the sky, you're looking that way in the helio-nonsensical model, and you see all the stars over there. So I say, look at, and then 6 months later, the Earth is all the way over here, and now nighttime is this direction. So if you're here and you looked up at the sky, you're looking this direction. How do you see the same stars? Right now, You're looking at one side of your room. How can you see the painting that's behind you?
But when you go to Australia, you see the other stars.
Okay, so let go back.
You can test it. You go to Estonia, from North America to Australia, you see the other stars. That's for sure.
Okay, I agree. You do. Yeah. But here's something they haven't taught you. Instead of believing that you're standing upside down on a spinning ball, think of yourself being in a large room. So you and I are in a room. It's got 10-foot high ceilings, and it's got recessed lighting, and we'll call those the stars. And we both look up. We see the stars. We can draw patterns, all as well. Now, I expand that room to the size of a city. Okay? Not even that far. Like here in America, we have these hotels in Las Vegas that are so freaking big. The hallways are so long that if you stood at one end of the hallway with the light over your head, the light at the other end of the hallway is touching the carpet because of perspective. It just goes and it literally touches the floor. That's just in a hallway. But now we expand this room to 10 miles away. I send you 5 miles away. I call you on the cell phone because I can't see you. I call you and I go, look up. Describe the stars. Do you see the bear that we drew when we were together? And you're like, I don't see that. I see completely different lights on the ceiling. And I was like, I see different lights on the ceiling. Hold on. Let me turn my lights off and put a big sun up there. Can you see it? You're like, no, I only see the lights in my ceiling. Okay? Because you're on other ends of the room. Perspective stops your vision. If the Earth were a globe, nobody south of the equator should ever be able to see Polaris because it would be below the curve, the physical curve. A globe requires a physical curve. If I was a boat, my fingernail was a boat, and I went over the horizon, it disappears behind a physical horizon. I could zoom in, still can't see it. I zoom out, still can't see it. Not until I come forward could I see it. So the globe requires a physical horizon. There's been observatories as far as 30 degrees south that have seen Polaris. Okay? That's impossible on a globe. Absolutely impossible. Here's something. So if we can see too far. So a 6-foot-tall person standing at the edge of calm water, according to the globe math that says the Earth is 24,901 miles around, there should be a 6-foot drop at 3 miles. So his physical horizon should be more than 3 miles. I mean, no more than 3 miles. Perfectly clear day. No more than 3 miles. But we can zoom in and see things. I can look right across Long Island Sound here, 5-7 miles. I can see people on the beach when I'm sitting at the water's edge. That's impossible. There would be dozens of feet of curvature, okay? But there is none. And here's one. This is in Aluja, France. Out here is Mount Canigou, but you can't see it. It's 175 miles away, okay? And the light that's bouncing off of Mount Canigou isn't strong enough to push through all that atmosphere, and you just can't see it. However, remember the sun migrates in between the two tropics, and twice a year it lines up with this viewing spot in Aluja, France, and Mount Canigou. The top of Mount Canigou, according to Globe Math, from this elevation, should be over a mile below a physical curvature, which a ball requires, a physical curvature. The ball requires a physical curvature, but twice a year the sun lines up, and look what happens. All of a sudden you can see it here because the sun's light is powerful enough to push through. It backlights the mountain, and we can see the whole mountain. The very top of this mountain should be a mile below a physical curve. So what we're seeing here is an optical horizon, okay? And that is impossible. Well, you can have optical horizon on a ball Earth because, foggy day, maybe you only can see a mile or less than a mile, okay? We can see things, we can measure things, and look, that is not a mirage, that is a mountain. It is there. When the sun is lined up with it, you can't see it, right? Here's a camera a foot off the ground. We can see the water. If you watch the video of this, we can see the water for dozens of miles beyond it, right? This should have 59 feet of curvature. Most of this oil rig should be, or all of it, should be hidden behind the curve, but we can see it. And now, worse than that, we can see the surface of the water beyond it. There is no excuse other than magical refraction, not refracting the water in front of it, refracting the water behind it, bringing it up to eye level and magically stopping there and looking like it's real. That's just nonsense. That is just clinging on to a childhood belief and not be willing to let go of your ball. A lot. You're a good listener.
Interesting.
Yes.
Interesting to search those theories also to sphere theories. And I will check it and I will find those.
That's good. Yeah. Yes. But here's the thing. Don't believe anything I'm telling you. I'm showing you that, hey, we've been brainwashed not to think certain ways. I'm pointing towards some doors, and then you can go find them. Right?
I will always think of my head with corona and whatever theories. I always investigate and search myself.
Yeah, that's good
for everything, for every part of the thinkers and theories.
There's a great flat earther that lives in Estonia. Einar, do you know who he is?
Yeah.
You know Einar. I don't want to say his last name because he kind of stepped away. I think he has work issues or whatever.
Einar Kuusk.
Yeah. Oh, there you go. You said it.
Okay.
He made some great films, but he took them down, and he was trying to get funding to do like a real project, and it's difficult to raise money. But that's unfortunate that he threw in the towel. Here's just another thing to remember. The limit of our vision is where the sky meets the ground. That becomes our optical horizon, right? If you're out and there's nice cumulus clouds, they're all sitting on a deck, and they're all like on a flat deck. It's like, always wondered that's very interesting how it's a flat deck. It's not a curved deck, okay? And then in the distance, they get lower and lower and lower until they touch the horizon. Like 30 miles away, the clouds look like they touch the horizon. But again, it's because they came together. If I zoomed in, you would see that they're really not together. Okay? So the limit of your vision is where perspective just brings the sky and the ground together, and then that's your perspective. So this guy standing here, he can see the same distance in all directions. Okay? Same distance in all directions. So if you draw a line across that, here's a straight line in the sky, and then you see this little curve here, and our programming tells us, oh, that's the curve of the Earth. It's the edge of the sphere. No, it's not. It's the limit of your vision. you see the same distance in all directions, whether it's a mile or 100 miles. It creates a flat circle around you. The sky comes down, and this is what we call our personal atmospheric dome of vision. We can, if I'm standing here, let's say I can see 50 miles in all directions, so my curved horizon is 50 miles around me. When I look up, I could probably see higher because the air gets a little clearer, so maybe it goes up to 100 miles, right? And if you charted all those points, kind of makes a dome. That's why we call it our personal atmospheric dome. But if you were standing 10 miles to my side, your dome would overlap my dome by 10 miles. You would see completely different things, okay? And here's another thing. The optics of the sky are no way to prove the shape of the floor. Look at the lights in your ceiling and describe the shape of your floor. It's a ridiculous thing to do. Look at the pool balls on a table and tell me what shape the pool table is. It doesn't really make a lot of sense.
But why those another planets show as shape and the sun look like the shape, not
you think that you could be
the
that
flat
you
one?
This is a new planet that NASA showed us, right? And NASA didn't make this. This is what's called a fisheye lens, okay?
Why?
This is actually just a gas tank, a dirty, dusty, paint-peeled gas tank, okay? All right? So when we look at other planets, right? This is another one I show. These are not planets. They're bottoms of frying pans, okay? But when we look at planets, this is what NASA shows us. And this is what we see when we use real optics. This is what we see. These things are here within the Earth system, okay? Now think about this, right? Have you seen the latest picture of Pluto, right? NASA took a picture of Pluto on a spacecraft that's traveling 60,000 miles an hour, some ridiculous speed. And it's going by Pluto, and it took a picture of Pluto. I'm going to show you the picture in a second, okay? So think about this. If you were on Pluto and you were looking at our sun, how big would the sun be? The sun would be like the size of a friggin' pea at best because it's so far away, right? It would be the size of a friggin' pea. How is that pea star sun lighting up Jupiter to look like this, where a spacecraft with a crappy camera on it can snap a picture at 60,000 miles an hour and then beam it back to Earth in high definition when we can't even talk to the guy that did the spaceball jump, Felix. At 120,000 feet, they lost audio. They couldn't even talk to him on audio at that distance. But somehow this thing can capture this. And coincidentally, there's a desert or whatever that looks like the dog Pluto from Disney. Okay? This is mockery at its highest, right? But here's the thing you have to think about. And this one, if you think about this is gonna help you see. So when we zoom in on planets ourselves and get video, this is what we see. This is Mars. What are we seeing here? Okay, it's not a rock. It's not another planet.
Or atmosphere.
Well,
disturbing.
This is this is what we see. Okay, these things are energetic. What am I going to say?
Plasmoids.
Well, yeah, we don't know what they're. They're energetic. That's not what I needed. Okay, this is the star Sirius, and all of the stars have different cymatic patterns to them. All right, when you look at these things, you can actually tell which one is which by you get used to them, and they're very, very interesting. But getting back to the distance Pluto is, right? Have you gone up and looked in the sky? There's been a lot of planets up at the same time in the last month or so. You can see Jupiter, Mars, Venus, right? Okay.
Our atmosphere is disturbing this, and this is causing this twinkling because our atmosphere is unstable with ozone
and it does each one differently, and they always look the same when you look at them on different nights with different atmosphere. I'm sorry, You're just saying things to defend an unsupported position. But think about this. The inverse square law of light basically says, let's say this is a light, and if I put a light meter on it, it's 1 lumen. 1 lumen, 1 lumen, 1 lumen, 1 lumen. Lumen is a measurement of light. Well, as that light expands out, let's say I go twice the diameter of this, so it's out here. Well, that 1 lumen just got stretched, right? So I put the camera on it, and if it's double the width, it's 1/4 of the brightness. So it's now 1/4 of a lumen. And if I double that again, and I put a light meter on that sphere of light, it's 1/64 of a lumen. It's 1/4. It reduces by 1/4 every time you double the distance, or if every time you half the distance, it's 4 times brighter. Okay, is it 4 times brighter? I think that's what it is. So the light that's hitting Jupiter, this dusty, dirty ball, okay, right? If the light that's hitting Jupiter, where is it? The light that's hitting this dusty, dirty ball from a distant, smaller sun is bouncing off of these non-reflective clouds and coming back to Earth so we can look up in the sky and see it brighter than a star. I'm sorry, I'm not buying that. Okay? This is what NASA showed us. This is when a probe or whatever was going by, and it shows us, look, you got winds going this way, you got the storm spinning the other way, and this is over just a couple of days or hours or as it was approaching, and it's constantly changing. But when we look at Jupiter, in the pictures that they show us, this is the famous one in 2014. Everyone's seen it, right? And this is one in 2.5 years later. It's the same exact picture. It's just darker. Every cloud is exactly the same. They're lazy. They're lazy, or they're just rubbing it in our faces, okay? This shows you that NASA's lying. Why are they lying? Because they have to lie. Planets aren't real. Planets used to be called wandering stars. They're here within the Earth system, and they have a lot to do with how we live our daily lives.
But explain me this: why we look at the sky, and why we don't see any planet like this or this or this or this? We look only stars as this. Why? Explain me this. Why we don't see those kind of planets and stars?
Because there are no planets. There's just lights in the sky.
But we look at the sky. There are only these kind of shapes. Of
no.
No stars like that.
So you're still thinking that we're a disk in space. We're not. You're still thinking that planets are rocks in space. They're not. They're energetic lights. That's it. And when you see a light in the distance, I don't care if it's a square light or a flat light, you're going to see it as just a circle, because that's how light works. Okay? All of the planets that you see are made up stories. They're made up to make you believe that you live in a world where you can go live on other rocks. That's why the moon landings, it's all to make you believe you can live on another rock. The founders of NASA included Walt Disney, okay? Occultists and Scientology. These are the people that founded NASA. This is all a mind game. This is all to control you and keep you plugged into the matrix, the heliocentric system.
But what about the moon? Is close enough, and the moon is close enough that we should prove or see them sometimes like this.
How far is the moon?
300,000.
Close. 238,000 miles. 230. Oh, maybe that's right. How did they figure it out?
It's how they did it. Measured the light time or something.
No, they made up a story, and it's all nonsense. They fired a laser at the moon. No, they didn't. They fired a laser at the moon and got a photon back. And then all of a sudden, after they went to the moon, They put a reflector there, and that's now how they know how far it is. That's all a made-up absolute story. I'm going to show you some pictures of the moon, and you tell me if the moon is a sphere. Is this moon a sphere?
Yeah.
Okay. A little tricky. It's a half a sphere. Interesting. Is this one a sphere? Is this one a sphere? Is this one a sphere?
Yeah.
Why? What makes you say it's a sphere?
It's looking like a sphere.
Okay. Well,
the same.
It's
the same
not.
Shape.
It's not. It's flat. Okay. Is this one a sphere? Is that one is this one a sphere? Yes or no?
Looking like it.
It does look like it, but it's not. It's a bowl. Okay? So what I'm saying is, unless you can touch it and measure it, you don't know what it is. I'm going to show you how about this? If you one of these orange dots is bigger than the other. Which one?
Orange.
Which one of those orange dots?
Which one of the orange dots? This one or this one?
Optical illusion. Both are the same size.
Yeah, very good. So there you go. You're with me. An optical illusion. Now I'm going to show you another one. This is these two tables. Are they the same dimensions, width and length? They're exactly the same. But even after I show you, your brain cannot reconcile that they're different, that they're the same. They're both exactly the same. So unless you can touch it and measure it, you don't know how far it is. And if you get into actually thinking the scientific method, with the brightness and the size of the things that they tell us, they're impossible. They're provably impossible. Let's take the sun, for example. If this was our sun, how big would the Earth be next to it?
I have saw the image. It's like a small
pebble right there.
Yeah.
Okay,
yeah.
So let's say you're on that small pebble on the tip of my finger, and I put the sun right here. If you looked up in the sky, what would you see? The sun would fill the whole sky, right? If the sun was literally a mile over your head, it would fill the entire sky. Agreed?
Yeah.
Okay. So the sun's right over your head. It's filling the entire sky. And we move it away. Why does it get smaller? Distance. Perspective. Very good. This is easy. Okay.
Yeah.
So we move the sun 93 million miles away. And it reduces from the entire sky, horizon to horizon, from your view, to the size of a small coin held at arm's length. That's a lot of reduction. It went from the entire sky, let me get through this, entire sky to the size of a coin. What if I made it twice as far? How much smaller would it get? A lot. How about this? Let's just be safe. 24 times farther. 24 times farther. It is scientifically provable that it is magnitudes too small for your eye to resolve. And the inverse square law of light would make it so dim that you couldn't see it. But let's just ignore that. Let's say we'll ignore that, the inverse square law. We'll pretend that light travels like a laser that doesn't expand, which it doesn't. But we'll just pretend. So 24 times farther away, it is scientifically provable, unseeable. Polaris, our North Star, they tell us is 48 times bigger. So a comparison will have to be 48 times farther. So 24 times farther than the sun is 3 light hours. And times 48, which is 2 days, it would be 6 light days. At 6 light days away, Polaris is scientifically provable at the size that they tell us. Forgetting the brightness issue, magnitudes too small to see. At 6, hold on. At 6 light days away, you cannot argue that we would not be able to see Polaris, but they tell us it's 433 light years away. 433 light years away. At 6 light days away, you can't see it. That's like if I had a penny right here and I say, can you see it? Great. I said, all right, now I'm going to go to Africa. No, well, where are you guys? I'm going to go literally to China. Can you see the penny? Okay, of course you can't. And that's the same thing with the stars in the sky. None of them make any sense. There's no way we would be able to see any of them. If the distant little sun can light up Jupiter, how come all of the stars don't light up our whole world?
They are distance away, and they will take time from stars to
light years, light travels.
Yeah. It will take time. A lot of time to maybe those stars light 300 years ago, 300 light years away, or even more. Their light will be here.
Cool story, bro.
2 stars are already dead. Yeah,
that's a cool story.
Yeah, but explain me why we don't see sun or moon sometimes like this or this. Please explain me, please.
Because they're not flat. They're lights in the sky. They're lights in the sky. The reason we don't see them, you keep thinking that the world is a disk. We're not a disk. We are the basement of the universe, and everything above us that we see is in the Earth system. They're small, they're close, they're lights. The only thing that you can honestly say about any of the lights in the sky, sun, moon, and stars, is that they're luminaries. That's it. You're believing that they're a shape, that they're a physical thing. They're not. They're clearly not physical. Okay? They're here within the Earth system. None of it makes any sense any other way.
Only the Earth is flat and the other are shape or what?
No, you're mixing models. The Earth is all there is. The lights in the sky are not the Earth. They're not planets. They're not physical things. They're lights within the Earth system. Get the planets out of your head. Get the flat disks out of your head. None of that matters. None of that is anything. You're mixing the heliocentrical matrix model with reality, which is we are the basement of the universe. Everything that we see in the sky is within the Earth system. Everything in the sky rotates, right? You believe that we live in this spinning optical, crazy, spiraling universe. Where'd I go?
This is true.
Yeah.
This is true.
This is not true. This is an animation. This is not true. This is hold. This is what they tell us. So how the sun travels 4.4 billion miles a year. It's going and going and going. How come when you go out tonight and look at the stars and draw a little map, next year, same night, same time, every star will be in the exact same position? How is that possible?
Yeah, how can star constellations be the exact same every night? Thousands of years.
Exactly
it will
the
take
same.
time in a galaxy to travel. It's huge.
But Eric, I just proved to you that the distances that we're telling you would make the stars impossible to see. You're disconnecting. You're not taking the information that I'm giving you and actually processing it, because every single thing I showed you negates all of your beliefs. Each one of them separately completely wipes out all of the stuff that you're saying. You are brainwashed like I was. Not insulting you. I was you. Okay? But once you look, all right? Eric, you need to you need to just do a little research each day. This is my app. It's called the Flat Earth Sun, Moon, and Zodiac Clock app. Did you guys get this for Eric yet?
Not yet.
Okay. So this app will show you what's going on. Every day there's a new video right here. And I just say, watch one video a day. When you're having your breakfast, just watch the one video. I do short ones during the week, longer ones on the weekend, and just watch one video a day. If you get anxious, you can hit this archive button and go back as far as you want for years. It's all categorized by years and months. Okay? And then when you say, okay, well, what about, ask me any question, because I have it. It's in the app under the question mark button. So, you might ask, what about circumnavigation? What about
gravity?
Gravity right there. So you hit gravity, and I explained a little bit, but there's a whole bunch of videos on gravity. Amazing stuff. Start watching those videos, then you'll be like, oh, that makes so much more sense. Okay. The app will teach you so many things. If you want to, like, if you're like, oh, I need some entertainment, instead of watching something stupid on a movie, hit this FE movies right here. There's a whole bunch of videos here. The first one is a bunch of Navy and Air Force military guys blowing the whistle on flat Earth. A great movie. 21 questions. I'll answer all your questions. And just start watching those videos. And once you do, you'll start getting it. There's tons and tons and tons of information in here. You'll never be bored again. And if you really love me, you can just click this, and there's endless interviews that'll just go on and on and on.
Like this one we're doing right now.
Like this one. It'll be on the top of that list as soon as you air it. So,
hey,
there
Dave,
you go. Yes.
Do you have this image or the picture where there is like a earth pond and there are other ponds or some kind of like a, very extended plane with the extraterrestrials and stuff? So maybe that would explain it more, because we would understand the extended plane thing.
Yeah.
So how big is this flat Earth, the miles, or how to explain this?
That's a great question. Let's go. So you've heard about the ice wall. Well, the ice wall is just the shoreline. Remember, I was showing you the Antarctic basin, and Antarctica is the shoreline. Antarctica is frozen because the sun doesn't get out that far. It goes to Capricorn, and then it comes back. Right? So here's the shoreline of our world. This is the container, the shoreline that holds in our oceans. If Antarctica wasn't there, the water would flow out. So this is how it's set up. This is the ice shoreline. And then what's out here? Antarctica could very well be bigger than all of the continents in the world. Or perhaps Antarctica is set up like this. Or maybe our world is set up like this. Okay? We live here. Here's Antarctica, maybe 1,000 miles wide, maybe more, who knows? And then out here is extra land, extra territory. If you lived out here, use your mind. Let's pretend this is the flat world. There's extra land, also known as extra territory, more land, extra territory. If you lived out here and came to visit me in here, what might I consider you? An extraterrestrial. An extraterrestrial. And where did you come from? Outer space. The outer space. Okay?
Extraterrestrials.
Extraterrestrials. And perhaps it goes on and on. Maybe there's more, right? Maybe this was a map that was found a Japanese, Japanese map shows like 30 some odd other continents beyond Antarctica. They're hiding more land. They're hiding free energy. They're hiding that you are at the center of creation. They're hiding the fact that you are at the center of creation and nobody has control over you other than in your imagination. They're hiding more land, more resources. They're hiding free energy. They're hiding the power of our mind. And I talk about the heliocentric system being the actual matrix. I'm not kidding. The movie The Matrix, Keanu Reeves, at the end, when he's unplugged, he realizes who he is. He takes his power back. He stops feeding the system. The system requires people like you to feed into it and to believe it and to defend it and not to actually think and use their God-given brain. Right? But once you see it, you're unplugged. You're completely unplugged from it. Right? And you guys think that...
how do you go there? Take a plane and go there.
Oh, great.
They will stop you. They will stop you.
Yeah. So let me show you that. So in Antarctica, the Antarctic Treaty, I showed you on... let me show you this. So on the right here, that pink line is 60 degrees south. Nobody is allowed to go beyond that, and you can't even see Antarctica from this line. It's too far away, right? And some guys, and it's done multiple times, and people, that got permission from their countries, they got there, the Navy stopped them, and they're stopped. So here's some fishermen that decided to go there. I'm just going to fast forward through this. They go, and then once they cross that line, all of a sudden a destroyer appears on the horizon, comes up to them, sends a drone after them, radios them, and says, leave the area immediately. Turn around, no excuses, get out of here, right? And then you're like, well, how do they monitor all of that space, right? Because if Antarctica is as big as they tell us, that is a lot of room, a lot of space to. I'm trying to find an image, but I guess I could do it this way. A lot of space to patrol. So in the app, if I click the color wheel there, the images, and I go down to Antarctica, where is it? So hopefully there you go. So these are all islands, all controlled by the Crown. They all have United Nations military on them. And then they have a mesh network of buoys all around here. Anytime anyone crosses into that, everyone's notified. Drones, planes, boats come out, and you are turned around because nobody is allowed to independently explore the outer lands of Antarctica. Remember the Falklands War? Falklands are off of South America. Why are we having a war out here? Okay, these islands are key in hiding the lie. And here's the other thing. The lie is less than 100 years old, right? They were still teaching flat Earth into the mid-1900s in most of the world, okay, including America.
Okay, I will take a light radar 22, and I will check if the those airplanes are going around to this Antarctica or not.
Well, there's not.
They're live.
They're absolutely not. They're absolutely not. And here's the thing. Since you mentioned planes, let's just jump into this real quick. Well, first you have to remember that radar, GPS, and plane routes are all controlled by NASA, and NASA are a bunch of liars. So let me ask you a question. Check this out. If this is the Earth,
okay.
You looking?
Yeah.
Northern hemisphere is on the top, southern hemisphere is on the bottom. If you were going to go from any northern location to another northern location, any combination of northern location to northern location, would the plane ever need to cross the equator?
Kas sulle ekvaatori peab üldse minema, kui tahta põhjast põhja minna nii-öelda põhjapoolusel?
Ei.
No.
Okay.
No.
You're absolutely right, and they never do. Very good. Pay attention. Don't Google why I'm teaching you. Okay? All right? So here is a flight from Montevideo to Perth, and it goes all the way up to Los Angeles. On a globe, they cross the equator and then come back down. Why didn't they just cut across here? And the answer is because, look, this is a straight line, and they stop here for more fuel. They cross the equator twice. Let's look at another one. This is important. Okay? Here's one. They go all the way up to Los Angeles again. Why are they doing that? Plenty of people want to go from here to Lima, Peru, but they go because it's a straight line. It's a straight line, right? There's dozens and dozens of these, okay? And they, again, Los Angeles again, weird, right? Why are they doing that? Why are they making these extra long treks, right? But he's plotted on a flat Earth map, makes perfect sense. Well, it gets worse because occasionally a plane will need to take an emergency landing. Someone's having a baby, somebody, got sick, right? And here's one where the flight was from New York to Hawaii, and they went 1,000 miles out of the way to land in Seattle. They were right here, and they went to Seattle. Well, if you look at it on a flat Earth map, Seattle is right on their flight route. Okay? Well, that could just be a coincidence. Let's look at another one. All right? Same thing here. Moscow. The emergency happened here, and they landed in Moscow, 1,000 miles out of the way. Moscow's right on that flight route. Again, must be a coincidence. Okay? Then we got one from Dallas to Beijing, and they went way out of the way to Calgary. The absolute insanity. Why did they do that? Calgary is right in line where they were going, right on the line. There has been over 16 emergency landings that prove flat Earth, okay? They're all documented in this book. You can get it free online, or you can go to lulu.com and order a coffee table version. But again, how many examples do you need? Southern flights to distant southern locations always cross the equator. Now, when I say always, there are some direct flights. They have some planes that go faster now. They use these wind routes, and they're big, huge variables in the amount of time it takes. But there's no reason to cross the equator when going from a southern to southern location, but they always do. But they don't in the north. Absolute insanity. It doesn't make any sense. It should be the same. Not.
Listen, maybe we go for some comic relief with ISS footage and things like this.
Sure. So, do you believe in the International Space Station?
Eric, do you believe?
I think Eric's had enough.
Yeah.
Yeah, but so we have those satellites and things like this. They're like in a lower atmospheric areas, not in the space kind of, right? Like satellites and all this sort of stuff.
So again, yeah. Well, I don't believe
in northern side.
So here's the problem. The problem is I don't believe that anything is floating in space other than balloons in higher in just above the Earth, 100,000 feet maybe. The International Space Station is about the same size as the 747. Here's the 747 transiting the moon. Both of these moons are the same size. Here's the International Space Station transiting the moon. Therefore, you have to assume that they're both the same size. Well, and at the same height. We know they're the same size. Sorry. You have to assume they're at the same height. This is a trick. NASA has outfitted some B-2 bombers with some transparent parts, LED lights, and they do these moon transits. They tell you where you can see it, all to fool people into believing the space station is real. Therefore, the globe is real. Therefore, you're insignificant. Therefore, you're flying through space in a distant god at best universe, and you have no power. We're running out of food. We're running out of fossil fuels. Another hoax. Nuclear bombs are going to blow us up. Another hoax. Okay? Nuclear power plants are on fire, going to ruin the whole world. Another hoax. Probably on fire. Nuclear power is just an advanced way to boil water. There's no such thing as nuclear power. The whole radiation story, Chernobyl, all nonsense. All of it's nonsense. Okay? And this is how they get you. If they can convince you you're spinning out of control, flying through an instant universe, a crazy universe, then they can convince you of everything, of anything. Okay? Right? They get our kids, right? That's the wrong one. They get our kids, and they convince them. Where am I? What is going on here? Oh yeah. So I gotta find a shorter version of this. Hold on, I brought up the wrong one. Here we go. So they brainwash the kids. This ball is a real ball. It's filled with helium. This is not real, but she's moving it around. Watch, I'll show you again. They beamed it in, And now she's manipulating it. It's called augmented reality. They're playing in a video game. She's looking either in a contact lens that's showing her where it is, or there's a camera or something behind the camera, and she's manipulating things in real time, just like they do in movies. But they barely do these live things anymore because it is they get caught too many times, right? This is a shot of a guy going around the corner. Watch, his elbow becomes transparent, which shows that they're using layers. Layers, okay? His elbow is transparent. His body's transparent. So this is a not a real thing. Let me see another one here.
So they took a telescope to look stars or something for yourself also.
Yeah, and why is it when we look in space, this guy, why I talk, this guy's floating on a friggin' harness. You can see it. He's hanging. He went by in the background to make these guys look real, okay? And what's interesting is these guys are doing the script. They're flipping their microphone around. Guy's flipping his hat around. In the script, this guy in the blue is supposed to hand his hat to the guy in the green, and he's supposed to put it on the counter. But he makes a hand movement. Again, ignore the guy floating, hanging on a wire, right? But watch. Here's his hat, and then he makes a hand motion with his right hand, and the guy thinks he's passing him the hat because he screwed up. He wasn't looking at the screen properly. So watch this. So watch. He moves his right hand. He thinks he's handing him the hat, and he puts it away. Okay, I'm looping it here. And if you look at his eyes, he's freaking out. The guys are both stumbling, right? Like, oops, he didn't hit the hat. The hat's not real. It's augmented reality. Okay? Mm-hmm. There's many
virtual reality. Mm-hmm.
Yeah. There's many issues with this. Okay? Here's another one. At the end of their live stream, everything that was floating, including them, glitched out. Shows that they're on a different layer. This is impossible. On if it was one layer. This shows you, this is an image of them all floating. They're sideways. Well, how's the fruit just sitting on the table like that? How's the fruit just sitting there? Okay, these guys are hanging from wires. This is an interesting one. Watch this. These guys are in front of a green screen, and you see these glitches and stuff, like the hand. You see the hand glitch there? Like the glitch. Watch under his arm. He'd make right there. Boom, green screen. Revealed the green screen. Okay? This happens all the time. I'm in front of a green screen, and it's better than NASA's. Hire me. I don't need $65 million a day. Just give me $1 million a day, okay? Right? We'll barely even crack your budget. I do much better CGI for you. Much better.
Can you show your green screen right now so that we could understand better what green screen is?
I can't even show my green screen because I don't know how to. But if I lift it up, there's my green screen. Okay?
Yeah, this is how it's done.
Yeah. Oops. Now you got me all screwed up.
Oh, it looked good. It was really convincing to see that, actually. So thank you.
Yeah. So it's absolutely crazy what people will believe, and it's so easy to fool people. Okay. What is this?
Yeah, other theories also. Yeah, other theories. I know.
Look at this. This is on a 0G plane where the plane's doing a parabolic arc, and this is where NASA practices. This is supposedly on the space station. Okay. And this was live on television. The news was like, we're going to have a rare talk with the people on the space station, or maybe it was Skylab, I forget. And during the broadcast, all of a sudden they slammed into the wall and they cut the screen. This was a live feed. It was done in a 0G plane, but they came out of the parabolic arc just a little soon. So I took the video, I flipped it sideways, and I compared it to the end of a parabolic arc where these people are floating, and that's when it ends. Same thing happened to them. They said it was a catastrophic, unexpected shift of the station that they're working on. Okay? They're in a friggin' 0G plane. They're busted, and that's why they don't do lives anymore. There's a lot, man. There's a lot. And once you understand that all space travel is fake, these billionaires going to space is absolute nonsense now. William Shatner in space, right? This is. Go ahead.
But do they actually believe it? Do they honestly believe it, or they're actually lying to us? Like let's say Elon Musk, he's seems to be really believing in going to the.
Elon Musk is a puppet. Nothing he does is real. He's not the founder of Tesla. He's just a puppet head for them. He's not the founder of SpaceX. He's just a puppet that says what they want him to say. He knows nothing. His tunneling company isn't real. He's not the of the Solar City. I mean, he came from a super rich family. All of it is lies. He's just a puppet. Okay? Nobody goes to space ever. Think about this. Where is it? So at any event, any public event you go to, right? What do they have there? They always have EMS workers. They always have an ambulance in case someone gets hurt. You're at a fair. Like I run a school fair. I used to. And one of the town requirements is we have to have an ambulance truck there in case somebody gets hurt. If you're having a town race, a marathon, a bike race, you have to have EMS. Always EMS, right? If you have a guy doing motorcycle jump, got to have EMS there. Okay? A 94-year-old man, slingshot into space, comes down to Earth, right? In the middle of a friggin' desert, slams into the ground, okay? Slams into the ground, right? No shock absorbers, bam, okay? Slams into the ground. First person to go see should be a doctor or somebody, okay? But that's not what we see. What happens is they bring up a red carpet and a stairwell, and then you got a whole bunch of liars there. Let's see. Let me just jump forward. Oh, all of a sudden, here they are. And they're coming out, and you got Jeff Bezos, the liar, and you got maybe his wife and a couple other bimbos. No EMS. No real reporters. This is a stage. Look, William Shatner coming out. My back would have been broken on that landing. Okay? Mm-hmm. Okay? This fat old lard should have shot himself. Okay?
Yeah, that's crazy.
It's crazy. It's absolute insanity. And if you really watch, the impact, it is, let me just show you the impact, right? Falling out of nothing could go wrong here, right? You guys are all frozen. You're all moving at different speeds to me right now.
Oh my!
Just like an explosion.
Yeah. Absolute insanity, right? Bam!
Did you have the cameras inside also of this cabin?
No, there's no video inside. Why didn't they show us video inside? And the other thing is, when they're in space. When they're up there, they said they got their 4.5 minutes of weightlessness. 4.5 minutes of weightlessness. Ignore the guy flipping in the foreground. That's P-Brain. He's awesome. But they only show us 5-second clips. Why didn't they show us all 4.5 minutes? Because this is pre-recorded in a zero-G plane. They always have a girl with long hair flipping around. A zero-G plane. It does a parabolic arc. They get a little footage. They splice it together. And if you watch the whole interview with Richard Branson, he's in a seat. It looks like he's going to throw up. Because they call it the vomit comet because people throw up. This is a zero-G plane. It's ready. It's about to take the arc. They get maybe 20 seconds of free fall. And then the plane comes out of it. And they're floating for 20 seconds. And that's how they do it. And people just buy it up. Because here's the thing. Ego is a tough thing. A lot of people have ego. Their whole life's been built around a ball. And when you tell them the whole life's a lie, they don't want to let their ego down. And they're like, I'm just good. Don't take my ball away. But once you understand that they're lying to you about who you are, the true power that you have, the true mission that you're here on, then you take your power back, and life only gets better. And you can talk to any of your friends. I bet they're never bored for a second. There's not a second of your day that goes by where you can be bored when you know the truth of this world and you're learning more about it.
So what's the current progress on going forward? Like, or somebody? I was watching one documentary, like 2-hour documentary, on like a Brazilian research team. It's called Convex Earth.
Yeah, that's a controlled opposition piece that is out there. They have a whole bunch of experiments that they never showed you the details of. They were actually impossible experiments. They're kind of believable, and then they go into this hole that were a disk in space with 2 ponds and Antarctica. It's controlled opposition. If you believe in that, they've taken you down a hallway that's a dead end. Right? That is 100% controlled. Then if you look into those guys farther, well, the main guy on there, he talks to an alien in the bush that talks with like a squeaky voice. Right? He goes to the bush and he talks to this alien every day. Okay? Dumbest crap ever. And it's all, look, zero-G plane, this is what hair looks like, but on the space station, whoosh, they got these afros that just float. They don't flip around. Right? And they do different techniques. They hang from wires. They have them in a zero-G plane. They use CG green screens. They do all sorts of stuff so you can never really figure out what's going on.
So is anybody planning to go for on the other side as well?
There's a guy. He's gonna trek to the North Pole. He says, I think it's a suicide mission. And the thing is, let's say he does it and he doesn't freeze to death. And at the rate he says he's going, it's going to take him 11 months. So 4 or 5 of the months, he's going to be in complete and total darkness. So that's going to be fun. And if a bear doesn't eat him and he doesn't run out of food and freeze to death, let's say he makes it there. If he makes it there, he's going to find out the truth of our world. And then all of the controlling, people of this world, they're going to just go, oh, well, he got us. Let's let him come back with his chips filled with, photos and stuff. I don't see how he's going to keep his batteries charged. I don't see how he's going to recharge his batteries. None of it. It makes any sense to me. He was interviewed on the last Globe Busters. It's a show that's on every week on Sunday, and it's a great show. Here's the thing. The guy's stepping up, and he's actually doing something. That's great. His mission, in my opinion, is hopeless, and he's going alone. Probably going alone because no one will be willing to go with him.
But that's some progress at least.
Yeah, that's something.
So what's his name again?
His name is what is his name?
Oh, this channel is pretty good. Globebusters YouTube channel.
Yeah, the Globebusters YouTube channel is fantastic, and it's a live show. You can ask questions in the chat.
It's live.
Oh, Ryan Zeheim. Ryan Zeheim. Yeah. So here on the app, on the friend finder, these are all the people that are near me. But if I hit the web button and I type in Estonia, boom.
Arto.
What's that?
Arto is there. Arto is the blue
so
one.
So you guys have some you got some people around there, and you know what? Right here, if this person message this person, you can tap on a dot and actually send them a message. You could set up long range sight distances. Go on Google Earth, see what distance this is, calculate the curvature, and if you guys can see each other, that proves the Earth is flat, right? But if you can't see each other, you got to look at what's the reason? Is it cloudy? Is it wavy? Is it they're like, you guys can't see me? That doesn't mean that the Earth is curved. That means that I'm too far away. I'm too small. You can't see that far, right? But this is an awesome place to do some long-range observations. And another thing is, if any one of you is one of the dots in here, you can hit your radius button, and you can send a group message out and say, hey, we're having a meetup at so-and-so or whatever. And it's a great way to find other flat earthers near you.
7 people in Estonia.
Right. So send them a message, do a meetup, start a Telegram group, start communicating. And then yeah. So, and it's great. There's people already getting married because they've met on the app. There's some. Yeah. Here's another cluster of people here.
Sweden.
Right. This is just the beginning. There's more and more coming. More and more.
Yeah, Arto should message these people.
Yeah, maybe.
So you mean that Earth is the center and the other lights and stars are
lights and stars in the Earth system.
Yeah, think of like Eric.
Earth system.
Enclosed system. It's basically, kujuta ette, Erik, et sul on piljardilaud ja üleval on need lambid lihtsalt laes, vaata. Laelambid võivad olla ümmargused, vahet ei ole, aga piljardilaud on sile, siuke tasand lihtsalt, vaata, kus elu käib. Me oleme siin tasandi peal.
Later we talk Estonian.
Yeah, I just told him about the billiard board. Like
what about the firmament?
Firmament. Yeah. The firmament is like a...
How can I explain the firmament? I've seen like rockets that go up and clicks, they hit something like they hit like something strong.
Yeah,
like a rocket.
Yeah, you saw the Go Fast rocket. So when rockets, when NASA shoots a rocket up, it's always edit, and then it curves away. It just curves out and crashes in the ocean out of sight. So
yeah, they curve. Yeah, I've noticed. Yeah.
So here is the Go Fast rocket, which is an amateur rocket shot up in the desert here in the west of the United States. And they gave us an uninterrupted view sideways. And this is a down view. And it went up 73 miles. And all of a sudden it went kerplunk. It hit something. It hit something more viscous, maybe plasma. I don't think it was like water. And then it floated very oddly. And this is actually very interesting. It floated for a little bit. When it turned on its side, it got a glimpse of the moon. So here comes the moon. This dot right there, that's the moon. Interesting, kind of flat horizon too. And so we looked at where the moon was, and the moon was over Australia when this was shot up over here in Arizona. Okay. How could we see the moon in there? If the Earth was a basketball, that rocket was a fraction of a millimeter over the top of it, and the moon is below the basketball. How could we see it? Impossible. Impossible.
But what is the moon, though?
Oh, I know. It's made of cheese, okay? Prove me wrong. I don't know what the moon is. And here's the funny thing. Think about this, okay? The moon. So focus. When the moon goes to a new moon, that means it's right near the sun. You can't see it. How come there's not a black spot in the sky, right? There should be a black spot in the sky, but people say, oh, well, the sun's blinding you and you can't see it. Okay. How come when we have a total eclipse of the sun, right? Total eclipse, that supposedly the moon is covering the sun, right? Right? Like this, right? Whoops, that's not what I wanted. So this is a total eclipse. How come nobody, no matter what camera you use, infrared, filters, nothing, how come there's no video of the moon? There's no features. Now, if it's a full moon in the middle of the night, full moon, and we're in the middle of nowhere, no lights, you can read by the moonlight. It's so bright. The light reflecting off of a dusty, dirty ball is so bright that I can read by it. I can drive down the road without my lights on because the moonshine is lighting up the earth. Well, during a total eclipse, the earth is away from the moon in front of the sun. So if you were on the moon right here looking at the earth, you would see a full earth, like a full moon. Well, the earth is 6 times bigger than the moon, they say, and more reflective, I would say, with its oceans. So the earth shine should light up the moon a minimum of 6 times as bright as the moon lights up the earth. no one has ever seen the moon approach the sun, eclipse the sun, or exit the face of the sun. Something is eclipsing it, but it is not the moon. It's not the moon that we see. Again, in the app, under eclipses, there's a whole bunch there, and there's a couple videos there that you watch them, you'll be like, oh, wow, that's amazing. And these are videos that if you Google flat earth eclipse, you're going to just get propaganda. Any search you do in Google, YouTube, that has the words flat earth in it, give you the same results every time, which is the clowns, Simon Dan and Professor Dave, who I call not Professor Dave. These are paid clowns, heliocentric occult clowns.
Pretty complex to navigate in this. A lot of news and things.
Well, here's the thing: the app. Here he goes selling his app. All right, the app is $3. All right. There's a subscription if you want to be able to send messages to people and access the weather and soon access the trivia game. But besides that, you get everything. You don't need to subscribe. It's $3. You have it forever. Go check out the reviews, and you'll see it's the highest rated in the App Store and the Google Play Store. Just be careful. Make sure you go and look for this icon and Blue Water Bay, because there's already a controlled opposition one by the Ron Media Group, which is literally the Flat Earth Society, that they're going to try to gatekeep you in, too. You go there, they feed you propaganda. It's nonsense. I get lots of emails, hey, your app sucks. I can't find this. I can't find the videos. It's like, it's not my app. All right? This is my app. And the best way to find me, all the stuff, just remember Flat Earth Dave, flatearthdave.com. flatearthdave.com. There's links to the app. There's links to my interviews. There's links to the lots of videos, my podcast. Plenty of free stuff there. Okay? Check it out, and you too will lose the respect of your family and friends because you'll be a flat earther.
I have one thing here to comment. This image just behind you here, where we can see the Earth and the Sun and the Moon right now, and the stars, and we can see the firmament. Erik, this is what is meant by the Earth system. That this is like an enclosed system under this firmament dome, or like some kind of like a shield or something, something, and under it are the sun, moon, and stars. It's everything in the Earth system. So,
and they're not balls of rocks and burning balls of gas. You know, if you listen to people like Eric Dollard, who's an amazing physicist or whatever, electrical magnetic physicist, he says the sun is a transformer from another dimension. Very interesting. But the sun that we see, I don't believe is the real sun. I believe the real sun is behind it. Again, watch the eclipse videos. You'll start to understand that. We don't have time to get into it here. But I think that the sun and the moon, this is just me, because, again, I can't reach it. I can't measure it, so I really don't know. But I've done experiments where I take a glass dome, and you get a glass paperweight dome and hold a light above it, and then look in the dome, and you'll see a sun in the dome, like floating in the middle of nowhere. It's actually amazing. Where'd I have that?
That sounds interesting.
Yeah, there's so many. I wish I had. Oh, here it is. Here it is. Try this. Oh, so this is just a model. That's not what I wanted. Take that off. So here it is. I got a light. I'm moving above it, and inside of it, it looks much better in person. It literally looks like a sun. And again, it stops here and it fades out, just like the sun fade out I did. So now I'm going to bring the light back. It's going to come across. The sun will appear on the horizon. It'll rise up. I'm just bringing the light across the top, right? And then as it goes away, it'll go down. It doesn't go below the bottom. It just goes away. And that's how we see. This might be our personal atmospheric dome, but because that creates the optics that I'm talking about. But to try it yourself, it looks just like a sun. Okay.
The firmament, if I may ask, that firmament is all the way to the like this
Antarctica.
Yeah, is it always touching it, or do you think it's just in the air at some point? Where does it finish?
I can't answer that. You know, it could go way out beyond. There could be dome inside of dome. There could be no dome. There could be a flat sky. Don't know. We're not allowed there. We're not allowed there. So I really can't say. My opinion, I don't know. I don't know. I always say, I want to say that I believe it terminates, but I believe there's more beyond it. It might be an energetic dome. It might not be physical. It might be something we don't understand. Like, think about this. When you're boiling a pot of water, you get a little bubble on the bottom. Now put yourself in that bubble. It's a dome above you, but it's not physical. It's holding the waters above. I believe that space is water. NASA tells us it is. Everything is docking, ships, the Sea of Tranquility. They're all nautical terms. Why are they using nautical terms? Okay.
What about the compass and that sort of stuff, like with the North and South Pole, like this compass thing, where how does that thing work exactly?
Compasses.
Yeah, it's just a compass. You have the manual compass.
If compasses were what they told us, they would, in the south, point to the South Pole, but they don't. No matter where you are on Earth, they always point to the north. Okay.
No.
They always point to the north. So that makes absolutely no sense. So if you're in the southern hemisphere, how the heck does it point to the north? And people say, well, the magnetic lines, go around, wrap around the Earth. Compasses have to be level. They always point to the north. And when you get out as far as Antarctica, guess what? They stop working. The North Pole is too far away and the compass doesn't know what to do. Compasses don't work in the outer parts of Antarctica, okay? And then if you look at a thing called magnetic declination, certain parts of the world, they say, all right, your compass, whatever it says, add 10 degrees to it, right? Because that's the real declination. That's just NASA trying to confuse you. There's areas of Antarctica where they tell you that the magnetic declination is 170 degrees. That means if it says north is that way, you have to adjust that way, okay? Bullshit. It's because the compass actually works in that area, and they don't want you to know it, okay? It's all ways to confuse you. Again, here's the thing. Don't believe anything I say. I pointed towards some doors. Do your research. The easiest way to do that research is with the app. If someone has a better idea, feel free. You can check out my website. It has links to my YouTube channels. Tons of information there. You don't even need the app. Just check it out.
There's so many.
Eric, give me your best. Give me before we wrap up, because I'm losing my voice. What's your best proof for the globe? Give me your number one globe proof.
Tectonic plates, gravity.
Wait, hold on. Wait. I said one, but you said tectonic plates. You're just throwing words out there. The plates don't move. The Earth does not shift. The continents are not moving. They're stationary. It's all a made-up story. Yes, there's earthquakes. Earthquakes are a whole nother rabbit hole.
How the mountains were created then?
Not the way that they told us. That's for sure. Okay? You have to start looking into the mud floods. Again,
what about the different cultures telling like 5,000 or many like 5 to 10,000 years ago, they all have this kind of flood story in them, like this like in the Bible there was also a guy who put everything in the boat to get away from the flood, and then what do you know about that kind of things?
Yeah. You're talking about the story of Noah's Ark. I don't believe the timeline that the
different cultures have it same.
There was a mud flood here. On a flood, how do you flood a ball? I could see you flood a basin, right? That's easy. You could bury the whole, just bring the waters in from above and flood the entire pond, okay? Because Antarctica is high enough to contain the water. You can't flood a friggin' ball. You can't have a ball with an atmosphere adjacent to a vacuum. How come a vacuum of space doesn't suck all of the air off the Earth? It's impossible.
Yeah.
These are things
magnetic field.
Oh my God! You're just throwing words out there. Show me an example in science where a magnetic field can hold air down away from a lower pressure system. The second law of thermodynamics says you can't have high pressure next to low pressure without a physical barrier. Okay, if you say, well, the magnetic force and gravity, okay, if I had a shoebox of air and I sucked all the air out of the room, in your world, the air would stay in the shoebox because gravity is holding it in. That's not what happens, okay? It adjusts. No matter where you are, you can take a straw, ground level, 1,000 feet, 10,000 feet, 100,000 feet. You could breathe in, you could drink water, you can suck air and water up and away from Earth with the weak, low pressure of your lungs. But the Tor 17 vacuum of space, which we can't even create here on Earth, they could do like maybe half of that, has 10-foot thick cement and lead walls, so it doesn't implode upon itself. But somehow the strongest impossible vacuum of space doesn't suck all of the air off of Earth. It's absolutely insanity when you actually think about this. And then if you listen to anything NASA says, they show us these nebulas. This is a cloud, a giant Oort cloud nebula that makes stars. This is a stellar nursery, right? The explanation is it's made of dust and gases. Dust and gases in a vacuum? What? And then they start sticking together and create stars. And after it creates a star, what does it do? Spit it out like a gumball machine? And then it trots away and parks itself in the galaxy? This is all fairy tale nonsense, okay? It's all insanity. And anyone that believes it is literally lost in space, spinning out of control. And you'll never know where you are. Now, many people are doing well in their lives. They're happy. They're doing their thing. Great. Life's a lot better than you realize. The world is a lot better place. And these bastards that are controlling us couldn't do it without our agreement, without us defending their heliocentric matrix.
I see only spheres in space.
Well, it doesn't matter, right? It doesn't matter what you say. It doesn't prove anything.
Sphere.
Moon, sun is move.
Hey, Eric, you're never going to see this. That's my prediction. I'm sorry. You think you see a sphere. Like I can show you a square light. I could show a fluorescent bulb at 5 miles away. You're going to see a sphere. Okay, I can show you an energetic pulsing orb, and then you're going to see a sphere. Okay, it doesn't matter. It doesn't matter. And yes, certain things are spheres. The Earth is not one of them, and neither are planets or stars. They're nonsense. Okay, the moon kind of looks spherical. Honestly, I don't think it's physical, but it does look spherical. It doesn't prove anything.
But we only see one side of the moon all the time.
Maybe there is only one side of the moon. I don't know. Maybe it's just a projection into our system.
Could be.
Again, guys, I'm going to wish you farewell.
Yeah.
Eric, get the app and just start watching the videos one a day, and then you can say I don't like it, I don't like it, I don't like it, right? And then one day maybe you'll see and realize that you're in a much better place than you think you are.
All right. So thank you very much, Dave, for your mighty effort here. And thank you, Eric, also for thinking along, and Koit for your questions as well. And I think we did pretty well here. And we got a great show, which was full of interesting stuff. So a lot of things to think about and do our own research. So that is what we all need to do to make sure which one is more real. And so this...
Always make my own researches.
That's right.
There you go. Absolutely. Make up your own mind.
Exactly. Okay. And I thank you all the viewers who have been here listening to Dave and all of us. So thank you for sticking with us all that long time. So yeah, meet you and see you in the next episode. So thank you and take care.